Okay, I'm going to wait a couple of minutes to make sure everybody is here. Once again, just making one more post and we start. Okay, I'm almost ready. Telling the people in the Discord group that we're having the meeting. All right. Okay. So let's start this thing. So basically, I've been contacted by several people, even DM, almost like worried. Several people that are worried about the situation. Let me find the here. All right. Um, about there are. I actually saw this video some time ago. Um, this fellow, he has a YouTube channel. He has a lot of followers. His name is the name of the channel is Crypto Crew University. Um, and also more recently Peter Brandt, that and also he's an analyst that has a huge number of followers, and I do respect both of them because they still do TA, but I don't like very much. So TA means technical analysis, right? So it sounds nice, technical analysis. I don't have anything against these words per se, but usually is it's kind of, I don't know how to describe it. It seems based most of the time on for the superficial from this, let's say, from the person that by the person that is not very knowledgeable about data and how stats work, etc. It seems logical, right? So there are some arguments that are presented, there are some indicators, and then some extrapolation is made about predicting things in the future regarding prices or market actions, etc. You can do it with stocks, with crypto, etc. The problem with these approaches is most of them are always delayed because they are predictive. They are delayed because they are based on things like moving averages, and because of, we don't have future data when you do these kind of things. The information you get from these indicators is always delayed. These indicators respond to facts. They don't predict anything. So that is one of the big misconceptions. There is no a single indicator that I know, the traditional ones, right, that are predictive because they take information in and then they calculate some quantity. Like the typical example is moving average, but the same apply with RSI, almost any other type of indicator that you can imagine. They react to the data, and it's okay sometimes because if I have a dip, um, then um, if after the dip happen, if it is staying there for a little while, I know it is a dip. You know, you can use kind of your eyes. It's just that if you have a noise, the moving average will smooth the noise. So it seems it's easier to see using the moving average that we have a dip, right? The pi cycle indicator that many people mention, it's such a type of indicator. It doesn't predict anything. It reacts to the fact that we are going down with price, and so it's telling us that we are going down. This is all what it does. Similar thing with so many other indicators that are based on moving average, RSI, Bollinger Bands. They always react to the situation, to the data, and they never predict anything. One of the things we do differently, because this is how science works, right? You're trying to understand a phenomena, and you're trying to model it with some equation that is supposed to represent the behavior of the system, and then you make predictions. That is a fundamental thing. I have even my Medium that you're seeing here. I have a Medium account where I'm trying to organize all my ideas. Eventually, we will have a real website, but right now, this is the best place to find some of my more organized material, beside the X and the YouTube channel where I'm doing this thing. Our entire approach is predict. And we have a video where we explain that, why this is different from anything else. And and that is based on science, based on some scientific argument of why the data is behaving the way that it's behaving. So we are trying to extract a signal from the noise and then trust the signal based on different arguments, periodicity of the data, the fact that the system scaling variant or whatever. Some of the same thing that the real science will use to make prediction about anything else, the orbit of planets, etc. Of course, because we are dealing with something that is much more complex than planets moving around the sun, how predictions are much less precise. Okay, that is a matter of course. They are less precise when you're dealing with physiology. When a doctor says, hey, you should take this medicine because I think that it will have an impact on you, he's also making a prediction, right? He's giving you a medicine that does work. There's so many people that did tests, etc. And maybe it doesn't work on you because it's so complex and all of us are individuals where, everybody responds slightly different, or sometimes hugely different according to your genetic makeup. To these medicines, okay? It's because we are complex systems, much more complex than planets, right? So, but it still works, okay? It works when you have a large population. In average, it works, right? It would be nice if we had individualized medicine instead of medicine based on averages and so on. With Bitcoin, for example, we have only one Bitcoin. We don't have thousands of experiments where we tested something like Bitcoin. Yes, there are the altcoins, but you should never compare Bitcoin with all altcoins because it behaves in a different way. It's its own thing. It's the other way around, where many altcoins kind of follow Bitcoin. So we use whatever we have, and so, but we are trying to do our best by applying scientific methods. Okay, and hopefully that works better than just doing TA. That's our hope. And if you look at backtesting, so if you look at the past and you apply these tools, you can see that it does work much better. Now, those will continue to work. We don't know, right? But it's our best approach. So this is what I'm trying to do in this article here, analyze with you. And it's kind of a rebuttal. Think also as an alternative point of view from what some of these people, like the guy at, I don't know his first name, but let's call him the Crypto Crew University guy in the video, and Peter Brandt, etc. And I'm not trying to put down completely their analysis because at least they are trying to use some logic and some methodology that is consistent, and so that has to be appreciated. It's good when somebody does that because there are other people that just wave their hands and say, "Oh, this is my opinion." We don't care about your opinion. We care about you giving us some logical arguments that have a chance to maybe be true, and then we want to use this information to make our investment choices. But okay, so here I'm going to give you some alternative point based on my understanding of how to use science to actually approach this particular topic. Okay, so we can dive in a second. I'm going to check if anybody's actually following live. Okay, there are a few people. Hello, hello everybody. Thank you to be here. Um, okay, so if you have any question, please, I can see your chat. Ask any question. You can interrupt me um, at a regular. Hey, Campy, everybody. So I will answer your question on a regular basis. I'm going to check what you write, and feel free to interrupt me if um, you see something that you want an explanation for or whatever. By the way, I like Medium. I don't know if you have a subscription. Of course, subscription here, subscription there, but I don't think you need a subscription. But I like this um, little button that reads the article for you, because sometimes you are in the car, you can click the button and you can listen to the article instead. But I even when I like actually to read my own article, because I like the auditory input. It helps to read and listen at the same time. It's really cool. It's this function where you can actually read the article. Anyway, so let's go through it. I called it a scientific approach to estimating the size of Bitcoin bubbles. And I don't want to go. We could watch together part of the video. I don't know yet how to do that. Eventually, I will learn how to do it where you can actually listen. I need to learn this kind of video making stuff. So I don't want to go back and forth between the Crypto University um, video, but I linked it in the comments, so you can actually watch it later. But you start saying, uh, you will hate what I have to say, but it is all based on fact. Okay, that is part of the problem, right? We have facts, and we have to interpret the facts, and also how you extract the facts. But we should call it data, right? That is a real word. So we have some data from the charts, from the online, from the on-chain information that we can download, and so on. And then it's a question of interpreting the data, but also how we get to data, which data we are paying attention. Is this important? Is this important? Is this noise? Should we take this piece of information here versus there? You need to find a method that makes sense, right? And there is already a problem uh, what this guy did, and what Peter Brandt did, and I will mention in the article. So this is why it's not fundamental for us to go and check what they are saying. You can check it yourself, but I do mention it in the article. It's very here is more about Peter Brandt, but Peter Brandt. When I read Peter Brandt, I remember the argument from Crypto Crew University. So I don't know who came first. Maybe different people did it independently, or maybe they presented work from others, claiming it's their work. I don't know which one was first. It doesn't matter. But they are kind of aligned in saying similar things. And I mentioned here in the article why I think these arguments are wrong. Okay. So for these, you're maybe familiar. So when you have time, go and look at my other articles on Medium. Okay, because I wrote a bunch of them, trying to make different arguments about different things. But really, the main one is this one, the Bitcoin power law theory. So if you didn't read it yet, please do, right? Because we have this view, this understanding of Bitcoin. I'm saying this not to the people that are there, because probably you're in my X or from Discord. I see some Discord member. Hi, Russell. Um, but maybe this video is going to be seen by other people, and so I want to let them know that we have this theory that is a full theory about how Bitcoin works, because we identified very important connections between all the different parameters that are fundamental for Bitcoin, like the addresses, the hash rate, etc. And so we see an overall pattern that is very reliable in the price of Bitcoin, with this thing that we call the power law. It's basically a simple formula that says that the price goes up with the time to the power of 6. So if you double the time that you are, that Bitcoin has existed, we are expecting, 2 to the 6, that is 64 times more gains. It's a very simple idea, and it's very powerful at the same time, because it tells us that there is a very, very predictable path for Bitcoin. So this is what we mean for the power law, because actually later in the article, I will mention the relevance of this, okay? Why the argument from Crypto Crew University of Peter Brandt is flawed based on this Bitcoin power law theory. So if our theory is correct, then I think their arguments are flawed. And then, we say, this is what I was telling before, that we are focusing on prediction instead of reaction. And most of this TA analysis is always on reaction instead of prediction. And one of the main reasons why we think that the power law will continue to exist and Bitcoin is going to follow the power law is based on this idea of scaling variant. That at the beginning sounds like, this fancy term, what the heck even means or whatever, but actually it's a very simple idea. All what it says that Bitcoin found a way of growing that is proportional. So every time it grows by a factor of 10 in price, it does it in a way that also the time it's proportional. Almost, you can almost visualize like a triangle, right? So if I make a triangle bigger and price is it's this side, like the vertical side of a triangle, the horizontal side needs to scale up in the same way to keep that proportionality of a triangle. So that is the easiest thing to think about scaling variant. It's a very simple idea. Sometimes we get put off by terms because they sound unfamiliar, but once I explain you everything proportional, then it should be super easy to understand, right? So if you think about Bitcoin, so when you plot it in this log chart that we use to reveal the power law, because it looks so evident when you do this funny graph that, again, many people are not used to, where you take the log of a price and the log of the time. So when you do it in that way, then the price looks like a straight line, right? With these oscillations, but in general, it looks like a straight line. And so now you can think almost like a triangle, right? You can visualize a triangle where the price is the hypotenuse. The general trend is the hypotenuse. The price itself, right? The change in price is the this side, the vertical side, and the horizontal side is the time. And actually, I should say the log of price and the log of time, right? Because the log is important because it talks about scale. So when you're dealing with logs, all what matters, everything is proportional. What is proportional? The scale. The scale is proportional. The scale means changes in 10. So do you understand how it goes? It looks like a triangle in a log chart. What matters is the log. That means changes of 10. So every time you change the price by a factor of 10, you have to change the time in a factor of 10. And if you have a system that does this, and it has done it since it was like a fraction of a dollar or even less, and it has done it when it was $1, it has done it when it is $10, $100, $1,000, do you think it will change to go from 100,000, that is more or less what we have right now, to a million? No, it will not change, because it's almost like a signature. It's almost like DNA. You're seeing the DNA of Bitcoin when you're seeing that pattern. That is the idea. It's a very powerful idea, and it's used all the time in science, because you can look at the elephant growth of the growth of a truth, of a task, and it's the same pattern. I posted so many times in my X account. It applies to thorns, it's applied to shells, it applies to horns of animal. It applies so many different structures in nature that it's something that it's very well known and understood in science. And so if you have a tusk of an elephant when he was 5 years old, it looks exactly like that. It looks like a straight line in a log graph, where the x-axis is the age of the elephant, and the y-axis is the size of a tusk. So if you increase the size of a task by a factor of 5 or 10, whatever it is, then you need to increase the age also. So you can extrapolate what the size of an elephant task is by extending this triangle in this graph, in this log graph. And it's going to happen. It's going to happen because the laws that make the elephant task grow are not going to change, are the same. So this is why it continue to be scale invariant. And we have an entire video on that, right? This is why we have an elephant and so on. So you can actually click on the article and then on this section and watch the video to learn more about this scale invariance. Very well done. My son made these beautiful videos that are high quality. It's not me talking. It's actually high production video. So watch it when you have a chance, okay? It's very well. So, and then we talk about why we think bubbles are very fundamental. So basically, there are two stories with Bitcoin. There are the general power law story, the general trend, and then that is its own phenomena. And in a sense, the bubbles do not matter in one end. And that on one end means that if I average, for example, the price over and over again, like I average over 1 month, over 10 months, over 1 year, 4 years, the bubbles seem to disappear. And what you see is only the power law. What it remains is only the power law because they cancel each other. When it goes down, the price goes down, cancel when it goes up, and so on. They cancel each other. So the real story, the main story, is the general power law trend. But the bubbles are there, and they are very important. There was a period of time when I was trying to almost, kind of forget about the bubble or dismiss the bubble because I thought we were a distraction from the main story. But actually, that will be a mistake because they are fundamental parts of the story. It's not as fundamental as the power law, but they are also a very important component. So it will be an error to dismiss it for two reasons. First of all, because it allows us to understand Bitcoin better and understand what is going on and what is the nature of Bitcoin. And second, because as investors, we can use them. We can use the knowledge of understanding where these bubbles are happening, when they're happening, why they're happening, to actually multiply our gains. I just made some post online where I say, if you go all the way to, remember I say you multiply your gain by 64 if you just wait, right? Because this is what the theory says. The price goes up with the time to the power of 6. So you take 2, that is how longer you're going to wait. Let's say 2 times more the existence of Bitcoin, that is 15. So if you go in the future by a factor of 15 years, right? So if you go 15 years in the future, that is a factor of 2 relatively to where we are right now. You then take 2 to the power of 6, you get 64. That is just by sitting on Bitcoin. That is amazing, right? Or where do you find another investment where you can make 64 your money by waiting 15 years? And believe me, 15 years are going to pass, even for the young people, believe me, if you are in your 20s, 30s, look at me. I look at the mirror and think, where the heck is Giovanni when he was 25 years old? It's crazy. Aging is really funny. It's like it looks like you are inside this body that is not your body. It's like you still. Some people maybe are not like that, but for me, I feel like if I still was 25 years old. My mind, my interest in the world is the same, doesn't change. But it will pass. These 15 years will pass very quickly for you guys, and you will have 64 more times. But now, what about having? In theory, I calculated, right? I calculated, like if you follow, because we have this full theory, we made it better, right? This is what you do in physics. You first find the simplest possible explanation. Then, if there are things like in addition, right? When you say I try to shoot a cannon and hit a target, right? Like I have another tank, or I have like an enemy that I want to shoot. Well, first I need to understand the trajectory of a projectile without any distraction. So I don't include air friction, I don't include wind, I don't include any of this. because I want to go to the essence, and that is gravity, right? Once I understand gravity without all these distractions, I can add component because I will, if I simply shoot the ball like this, the cannonball like this, I will not be able to hit one. I will go, left, right, I will miss one. So I need to add all the other distractions. But now I can do it because I have a main equation, and then I can add them as corrections, right? It's more important correction, but corrections. And so these corrections can be added. I need to understand how they work, how friction works, how wind works, what is the effect on it. And I can add all these components, making more and more precise. Right? But with Bitcoin, we can do the same. We can add the bubble and the bottoms because we know where the bottoms happen. They happen at very precise places relatively to the power law. Like it makes me laugh and cry at the same time when there are some people who say, "Well, your power law is so imprecise. It's easy to make this order of magnitude prediction." But it's not. That is not what the power law says. The power law says it's a very general trend, and then there are fluctuations around this trend that happen at a very precise time. They have very precise deviations. It's not that the price is randomly anywhere around that. Power law. That is a misconception. There are so many fallacies. People trying to dismiss our beautiful theory. It is not beautiful because we made it. It's because Bitcoin is beautiful. Bitcoin is so incredibly precise and predictable. It's all about you're insulting Bitcoin when you are saying these things. You're not insulting my theory because it's not my theory. A theory is a theory. If it is true, then it's how Bitcoin behaves. You're insulting Bitcoin. you know if the theory is true. Now, I believe that it's true because there are so much evidence of backing it up. It's not something that it's not philosophy. I didn't wake up in the morning and say this is how it goes. It's all based on observations and math and physics about networks and other kind of stuff like that. This is what is different from anybody else. I don't know anybody else who's using all these scientific argument to back up their statements. Anyway, so when you put together the knowledge of a cycle, because that is the other component, we are insisting on that. There are two things. There is the scale invariant behavior, and then there is the periodicity. The periodicity is another thing that is very scientific. That is another place where you can be sure, not sure, again, 100%, because again, we are dealing with an investment and financial things, human behavior that is even less predictable than physiology, but it's not completely unpredictable. That is the other side of it. Some people think, oh, it's less precise, so it's completely unpredictable. No, it's something in between. You can still make predictions. They're not going to be as accurate as with the planet or even physiology, but you can still make them. And so the idea is that this periodicity and human very periodic. Like I analyzed data in the past. I was working on these gravitational wave detectors, $500 million detectors, super sophisticated. We are trying to eliminate all the influence from the outside with very sophisticated shock absorber. We have all kind of countermeasure because we don't care about human activity, right? We want to see the information from the stars, from black holes, from neutron stars. We want to eliminate human activity that is noise for us, right? No matter how much stuff we did to counteract very genius people from MIT, from Caltech, coming up with all this filtering of noise, to eliminate the noise. This detector, if you look at it, you can see the oscillation due to the days, due to the seasons, human activity. You can see people going to school and say that you can still see. You have to filter it out mathematically. You have to use all these fancy mathematical tools to filter that noise because it's weak because we try to filter it out, but it's still there. And you can see people follow very precise pattern. They follow the day pattern for sure, the 24 hours pattern. They follow the season. There is more activity during certain days of a week versus others, right? There is seasonal influences. There is all kind of activities. Even human beings. Another thing. This is why it's cool. One of the few scientists that actually look at data in many, many different contexts. Like not many scientists have this experience of looking things from finance to astrophysics to physiology. Like another thing that we had was when I changed field and I went to study human physiology neuroscience. But my lab also look at what are called circadian rhythms, and these are things that you do, physiologically, even just moving, how much you move, based on this cycle during the days. Um, and one of the things that we did, we track them with a sophisticated Fitbit. Like instead of $200, it's a $5,000 Fitbit that we gave to people. When we do the studies, thousands of people, and we study, we get the raw data differently from, we don't get like, oh, this person did 1,000 steps. Like we get the raw data, how much we moved and fast we moved and so on, all from your Willis. And guess what? It's full of power laws there too. There are all kind of nonlinear phenomena, all kind of interesting fractal behavior. It's really crazy, and it's very regular too. Like different people have different rhythms. Like it's kind of, this why it's called circadian rhythm, right? Because it's circa dia, so that means about the day. It's not exactly 24 hours. If you take Campi, um, maybe Campi has 23.45. Okay, then you take Aviside, and Aviside has 24.2. Everybody has his own little circadian rhythm. It's completely crazy. It's almost like DNA, and it changes, with age. As you become older, it changes, it becomes less regular. But people have their own clocks inside. So it's this thing that human beings cannot be predictable, and they cannot be regular, and it's completely wrong. It's completely wrong. If there is any theory that says that, stay away from that theory, because it's not true. We are part of nature, and so we are predictable. We have our own rhythms. We follow periodicities. Yes, there are certain things where we have free will, but many others don't. Because think about it, right? We are this complex machine. If we had to keep track of our heart beating, we will die almost immediately. Okay, I need to make the heartbeat. Oh, my breathing. You will die. There are a lot of things that are automated, and so this is why we are predictable, because a lot of the things that we do are actually not guided by our will, are guided by these other things. So when we interact as people, even more. This is why, uh, you know, please don't make this argument ever. Oh, because this is due to human action, then it's unpredictable. It becomes more complex. It becomes more complex, more complicated. Yes, that is true, but it's not true that it's unpredictable. So the bubbles are an example of this, because basically the bubbles, yes, they are linked to this halving process that is programmatic, right? So it's not part of the human decision; it's part of the code of Bitcoin. It's there, because the other thing that we forget, that Bitcoin is not due only to human action. There is also code, right? So it's the combination of the two. There is a code that it does certain particular things. It uses energy. It's machine. So it's this interaction between human and machines. You will never be able to understand Bitcoin unless you understand this very fundamental point. That is this dance between human action that is also predictable and can be described by math, and computers that are even more, for example, the halving, it happens. Now, the halving also, it looks like a little bit like physiology if you think about it. Why? Anybody knows why I'm making this analogy that it looks more like physiology than something that a computer will do? Why is that? Why I'm making this analogy? I'm trying to say that it's not that regular, right? Like if it was like it's programmatic, it's all code, but I would say try and mimic a little bit physiology, because of what? It's not that precise, right? It's like if I did a computer code and they say every hour ring a bell, right? It would be almost perfect. Like, and even there is some little fluctuation, but it would be almost infinitesimal, right? But it's not that perfectly regular when we have halvings. Why? Anybody can tell me in the chat? Anybody can guess what I'm talking about? No? It's because the blocks, right? The blocks are not 100% precise. They are supposed to be 10 minutes. Right, right. Because they are not exactly 10 minutes, right? So it depends on how much hash power you have, and that depends by human action, because there are some people that decide, okay, I'm going to get more machining, right? It's a kind of somehow random process. And then there is the difficulty adjustment that controls it. If it takes too long or too short, then it corrects it, right? The difficulty adjustment changes according to how much hash power there is, and that is kind of a random process. So these blocks are never 10 minutes exactly. So, and the halving happens after a certain number of blocks, right? So if the blocks themselves are not perfectly 10 minutes, it changes. So if you actually go and check when the halving happened in the past, it's never exactly at the same time periodically, right? There is some room there. But then the reaction of people to this halving, there are a lot of things. So this is why you should watch this other video about why bubbles matter. We go through our reasoning, our point of view, based again on fact. We could be wrong, but we have our argument to state this. It has nothing to with the supply chain, at least for the investors. Now, the fact that there is a reduction in the production of Bitcoin impacts the miner, for sure. That impacts the miners. And the result, though, that is something that most people don't expect, is that actually nothing changes for the miner. Because basically it's compensating for the Moore's law. If there was no the reduction in supply, they will get an advantage over time because as time passes by, the machines become more efficient and they will start to mine more Bitcoin they are supposed to. And because the system wants to keep everything in balance, and I don't know if actually Satoshi was such a genius, that kind of genius where he already understood that this was going to happen, and that was the reason why introduce the halving. I don't know, maybe not, or maybe he had more in mind like something that is deflationary in time, but the effect is the same, right? Even if he didn't plan for it, the effect remains the same. Remains that what happens is that basically when you look at the arguments that we are presenting in the video, the miners need to buy new machines. They will have to buy these machines anyway because wear and tear. They update, they get better machine, the entire infrastructure becomes better and more robust and more secure. And at the same time, nothing changes for them in terms of rewards. They get the same rewards. And so that is incredible that the system balances in that way. But then why the price goes up like crazy? Just after the halving, we start to see these balls, right? It usually works in this way. That is part of what once you start to add all these other things to the general theory, it becomes like a full theory, right? It has all these components. It doesn't have only the general power law theory. I know it's called the power law theory, but part of it is also understanding the cycle. And so the theory says there are 2 years of when we go along basically the power law, and then after the halving we have another year where we have where we go in bubble territory, and so it's very precise. It lasts 2 years at the bottom, and it's not really a bottom because it's not flat. We are going up. Power to the 6 is still bull, right? It's less bull than the crazy bull market you have after the halving, but it's still bull. We basically have just 1 year of bear. That is when we are coming down from the top. So we have these 2 years where the price goes up with the power of 6. Then we have 1 year after the halving, we reach the top, and then we go down, and it takes again about 1 year to reach the bottom. So very, very precise. This is what happened for the last 3 cycles in a very uncanny particular way. Now, why we have this bubble, right? We think it's all FOMO. It's all FOMO because people know that something happened, that there are the halving happened. There is, even if you don't think, like I'm pretty sure that people don't say, oh, the miners got new machines. It's increased more security. There is all this update. Let's go and buy some Bitcoin. That is not what happened. Right? With a lot of different things in human activity, we do things, but we don't. Maybe we think this is the reason why we do it, but really it's because something else, right? It's all this activity, all this excitement, Doesn't matter what is the reason, doesn't matter what people think. Maybe they think there is scarcity, maybe they think that I don't think that too, because I don't think there are many people saying, oh look, it's more scarcity, let's go and buy more Bitcoin. You just somebody starts to do these things, and most of them are actually long-term holders. There is a lot of things happening, more videos happening, more YouTuber getting active, more people coming to X to discuss Bitcoin. There is a lot. It's almost like Christmas, right? We don't know. It doesn't matter what is the real reason for Christmas. For some people, it's more spiritual. For other people, more commercial. There is a lot of things happening during Christmas. A lot of activity. That is the same thing. Is the Bitcoin Christmas? Okay, and so people get active. They start to buy. The price goes up because there is excitement, and of course people want to. If there are a bunch of people buying, there is they are pushing the price up. It's not a question of scarcity, because the market's still liquid. In fact, it's even more liquid. There are more buying and selling, but the price tends to go up because it's what happened when there are a lot of people wanting to buy something, and it goes up. When it reaches a top, and the same people that actually are the long-term holders, they sell, and the price crashes, right? Because when you start to have a lot of people selling, of course, the price goes down. A lot of people panic. They start to sell at even lower prices, and there is this cascade where the price crashes and it goes all the way to the bottom, right? And then the cycle starts again. So this is what happened for 3 times, right? And so it's a very fundamental part of a history of Bitcoin. So here you have a model of that, right? Here is now the log chart, is a log linear chart, but we still fit it to the power law. The power law is supposed to be like in the middle here. These are bands that are deviations from the power law. The stars are the halvings, where all the halvings are appearing. This is a little bit older data, so we are after the halving here. So this is a chart that I did some time ago, but we are more or less here now, right? We are after the halving. We're not yet at the next bubble. These are supposed to be the next bubble. It's a little fuzzy because I introduced some noise, to kind of imitate the price, what the price will look like. Of course, it's much more regular because it's a simulation, right? It's supposed to, models are always supposed to be simpler than the real data. If you had a model that tracked perfectly every single thing, it's probably something is wrong because nobody has that level of precision, and also, in a sense, will be useless because we want to have a simplification of what is going to happen, and you can see the simplification of it is the black line. So the blue line is the real price. The black line is a simplification. It does a pretty amazing job in following the past data, and the idea is that we are projecting it in the future because we are thinking that it did such an incredible job that probably these patterns will continue to exist in the future. Now, why I didn't model the first bubble, that is kind of an essential part of what comes next, is because it's very, very regular in comparison with everything else. It doesn't happen at the right time when it's supposed to happen. It doesn't have the right height. But all these will be bad arguments to exclude something, in particular when we have only 4 data points, if you include this bubble, right, with 4 bubbles that we got so far. It's a good argument if you include the fact that it happened before halvings. So because all these guys are at very precise distances from the halving, we can imply that they are due somehow to the halving. At least this excitement that comes after the halving, people, the miner bringing an update to the infrastructure, all these things that we are claiming produce the bubbles. And because this one, it happened before we had our first halving here, we can make an argument that it should be excluded also because, like I said, it doesn't behave like the other ones. So we are going to exclude it. Now, of course, one day will be nice to spend some time if we really want to understand Bitcoin, to understand why it happened, what made it happen. Maybe we can get some insight about bubbles in general. But right now we are excluding it from the analysis, and this is why we don't include. But if you forget about this bubble, you can see that everything else, right, even the behavior of a bottom here, even during the bubble, right? It seems that it's following very well that behavior, and then it follows every single bubble. Now, what did I include here? So I included three components. I included in this black curve, right? The black curve is what we call the full model. The full model has the general power law trend. It has one more condition, but basically, when we are not in bubble territory, we are pushing the this black line all the way to the bottom here. And the bottom, like I said before, is not that the dot can be anywhere, the price can be anywhere at any time. It kind of follows a very precise pattern. Here was almost uncannily crazy precise, but it did follow this bottom there, very nicely. And then, kind of here, right? You see, it's oscillating, this going down and up, and here, for example, this is COVID, this bottom here. So there was maybe some news, some other thing that perturbed the price and made it more optimistic and more bullish than it was supposed to be, because it was supposed to be close to the green line, right, to the green band, within the green band. And then the COVID kind of was almost like a resetting. It resetted the system and say, you were too bullish. Let's go back to where we are supposed to be. In fact, you can see here, this deep here is the COVID, and we touch that green line bottom, and then we bounce back, kind of crazy. Just after the halving, we went up, and then there was a double top. That top was not supposed to be there. Who knows what happened? Again, maybe something that made the price very bullish, made it go there. But it's amazing. There was another top when it was supposed to happen. That is how incredibly Bitcoin is. That even when it's supposed to do things when it's doing things that it's not supposed to do, then it does the thing that it's supposed to do anyway. So this is why we can rely on this periodicity. Now the problem is we have only three bubbles, right? So when you're trying to do like a statistical argument and you're basing it on three bubbles, it's not going to be this amazing, tight argument like if you had many, like you had hundreds of these bubbles. So for example, with the power law, we're using all the data points. We have literally thousands of data points. So this is why the general trend is much better, much stronger component of the theory. You understand? While these bubbles, it's our best attempt to describe them and to understand them, given all what we have. We don't have hundreds of bubbles. We don't have hundreds of other experiments. We cannot go in parallel universes where we had other Bitcoins and study what happened. We don't have them. So you could do a simulation where you can try to run it. I did it, over and over again with kind of the same inputs that you have, but again, it will be based on anyway the data that we have, right? So you will not gain so much insight from that. So we are trying to do the best thing that we can. And and here you see also we have a spiral clock, but basically we're trying to emphasize there is a very strong periodicity in how Bitcoin does things, right? It has the tops are supposed to be all close together. The bottoms are all supposed to be together. So somebody else did something similar, so I need to mention it, right? Because it will be it's important to give credit to other Bitcoiners or other data analysts when they do something amazing. So this idea of putting Bitcoin on a spiral clock, not the spiral, because spiral is my contribution, but on a polar, what is called a polar chart. That means basically you transform the data where it becomes a circle. And it's not something that, so the guy that did it is called the irrational root. But again, we disagree on certain things. It tends sometimes to go a little bit on we're running. He got offended when I say that, but it's kind of true, right? He was trying to make an argument that there is less and less Bitcoin available. And I don't like that argument. I don't think that is true. But besides that, he's one of the best analysts that I have seen, because again, he's trying to do things that are a little bit more scientific. I don't know about his background, but the way he treats data is more like a scientist than other TA people. So he's one of the people that I recommend to follow. It's very good. We don't have to agree on everything. If when somebody says stuff and does stuff, it is still logical, still good, etc., based on some real data, maybe the interpretation of the data, maybe how you're playing with the data is not. I don't agree with it, but if you're doing it in a transparent and logical fashion, then I have just compliments for that person. Okay, he's just one of us. He's one of the warriors, But then when you do something that is completely bullshit, like Plan B and S12, I'm going to say it's bullshit. This is how I am. I am like that. Okay, I'm telling you, you're the most amazing guy. I want to give you a hug when you do good work. I'm telling you, it's bullshit, and it's bullshit. I don't know what to say. I'm like that. I'm open. I'm direct. I'm not passive aggressive. So, but anyway, look, he's very good. He put the data in this way. My contribution to my improvement was to show that if we put this is what you're seeing here actually is the full model, what I just showed you before, the black curve. Now it's a white curve, and you see it makes this beautiful spiral. You will never see that beautiful spiral if we were not dealing with something that is so incredibly regular like it is Bitcoin is. And this is why it looks how this amazing beautiful spiral is. So this is my contribution. The blue curve is what the rational root will have done. I think we do it slightly different too, but because when you look at this data, it doesn't look exactly like mine, but it's the same idea. But he didn't invent, he didn't invent it, right? Like I didn't invent the power law. The power law existed before me. This type of graph existed before the rational root. It's just that nobody ever seen it applied to Bitcoin, and it's still an amazing contribution. Like I want people to give me the credit for plotting Bitcoin like a power law. He should get the credit for the polar graph, right? I just took his idea and I expanded on it. So I added that spiral, and then it came to my mind to show it like a clock, right? Then organize. I think again he doesn't organize it in the way I do. I put the tops at 12 o'clock. If this is a clock, then we have the tops on 12. Then we have the bottoms at 3 o'clock. And then 6 and 9, right? So this is like time, right? So like if it was one of these analog clock that younger people have no clue what I'm talking about, but hopefully it's simple, right? So this is 12 o'clock, this is 3 o'clock, this is 6 o'clock, right? So every time you have a 90-degree, it's basically 3 hours in the clock. But for Bitcoin here, because one entire cycle is supposed to be 1 year, it's just it's 1 year. So from here to here, there is 1 year. From here to here, there is 1 year, and so on. It takes 1 year to go from the top to the bottom. All the bottoms are supposed to be here. Within few hours. Like usually within an hour. So when I say three, it could be 2:30, it could be 2:49, and every minute in this chart is supposed to be 2 days. That is how cool it is. So you can go from time to days in the cycle of Bitcoin. It's hopefully it's a useful idea. So right now for example, we are around 7:05 or something like that. This again, it's a older picture, but we are supposed to be 7:05. And so when everything happens, and also even if nothing dramatic happens at these transition points, these are also cool places where you can have in mind, because something happens, kind of at least in the quality of the data. So here, for example, we just added here, this was in January of this year, right, a few months ago, we added this transition from the bear market, and again, it should be called bear quote because it's still basically these 2 years where we're going up like this, you're following the power law. So these are the 2 years, right? So this is the first year. So this is when we go down from the top. This is the first year when we are there, at the bottom, but we're still going up, right, in general. And then we spend another year continuing along that general power law trend that is this. And so you can say the middle is kind of leaving the bear market behind, right? And then, but it's not yet the full frenzy bull market. That happens at night. And that is basically the end of this year. So right now it's about 7. It takes another 2 hours to arrive here, 2 Bitcoin hours. And that is about 240 days. So it's going to be at the end of this year when we are going to see real crazy action. And then there is 1 year of crazy action. We reach the top and everything starts again. So these are the cycles based on 3 observations. Okay. So one has to take them. It's really fascinating. It's amazing that Bitcoin did all these. I think there are real physical reasons like the mining, etc. But one has to take it with a grain of salt. Now we go to basically this argument that Peter Brandt called it exponential decay. The guy at Crypto Crew University, he calls it the 5.3 argument or whatever he calls it, something like that, right? And what that argument is, I watched the video and I need to watch it one more time, but they kind of do this. It seems that they include always the first bubble. That is the problem, the beginning of the problem. The first bubble, like we mentioned, doesn't have anything to do with the other one. So you're already polluting your data by including something that doesn't have anything to do. It's like I'm studying 3 cats and then I add a dog to my analysis. It's going to make it wrong, right? It depends on what you're doing. If you study mammals, yes, but then you're still maybe it will be nice to have 3 dogs and 3 cats, right? So you kind of balance it. But if you have a dog and 3 cats, you're going to make some kind of error by including the dog. So take out the dog. It doesn't look like the other guys. So that is part of the problem already, right? Including the first bubble. And then what they do, they look at the bottom and the top, the bottom and the top, the bottom and the top of each cycle. Now it's arbitrary. What they are considering, where do you consider the beginning of a cycle? Are you considering it at the bottom, at the top? You could choose anything, right? You choose halving being the beginning of your cycle. You could choose the top. You could choose the bottom. It seems here they're using the bottom as the beginning, and then the top, the following top, as the end of a cycle, right? So we are doing that, the next bottom will be the end of the cycle, right? So the bottom, top, and then the next bottom is 4 years, right? But okay, it's methodic. So when you do things like that, the most important thing is consistency, right? So independently of any other thing, if you are not consistent, then there is a problem. And to me, there is already inconsistent by including this bubble that has nothing to do with the other bubbles that are due to halving. They have a different nature. So why do you include the first one? Simply because probably gives them more data points, and this way they make the argument stronger. But we should eliminate it. And so what do? They take the bottom and the top, and they measure the change, right? And you can see, in fact, that the first one is kind of a hard factor almost, right? So they go down. This is how much, and you can see there is a clear decrease, right? There is a clear path where we go down more and more and more. The first one was amazing. Was this huge big increase. Then it decreased less and less. The top, right? The difference between top and bottom is decreasing with time. And the idea is there a particular pattern? So they are claiming that if you're taking the ratio between, let's say, this guy number and this number and this number and this number, you get 5.3, basically a factor of 5. And so they say, oh, this is now due by chance because there is a very precise pattern. How is possible that it's 5? Well, first of all, you're still dealing with a few numbers. We already say that the first one probably is not a good idea to include it. And if you rely on the ratio, by the time I take this ratio and this ratio, I have only two numbers. So if your entire argument is based, let's say that we eliminated the first one, right? And then we just rely on these three. So we have 3 data points. We rely on the ratio to make any statement. So now the ratios are 2. We are only 2 numbers, and we are making a big deal that they look the same. Well, okay, it's interesting, but we need to interpret it better. We need to understand it better. There is there are a couple of problems. The first problem I'm mentioning how they are using the first bubble. It's not just the problem of using the first bubble. If you're using the first bubble, then you are actually, if you go back here to the graph, let me show you what happens. So if I use these as my first bubble, and then I choose somewhere here, so where was your bottom, first of all? There is now a previous cycle where you can say, oh, that was my bottom. Where is your bottom? You will have to use some kind of artificial place to decide where your bottom is. It's like where is going to be the bottom there, right? So I don't know what they did, but they choose some kind of place where it's supposed to be the bottom. Maybe like the minimum of this data set, because the data set starts in 2010, because this is when we started to have markets. So it's very arbitrary where they start here. Then this becomes messed up because supposedly, right, if we believe in this cyclic idea of Bitcoin, the best and consistent way to find the bottom will be to go 3 years back in the past from the top. Because remember, there is 3 years between the the bottom and the top, 3 years. So if I take this as my top, like they did, and I go back 3 years, it's here. It's before this bubble. So you see how messed up all this is? It's, by including this bubble, you're actually introducing already a bunch of errors, a bunch of inconsistency. We are in errors because we are inconsistent. You're not even following a consistent approach, because here, then we do take 3 years from the bottom. Here we take 3 years. So we don't do it here, because if you did it here, you will have to go before the bubble. So what does it mean? Nothing, right? But if you include this bubble, then you're the bottom of this. In fact, we take it here. So for this bubble, the bottom is here, but it's not 3 years. And for the other two, it's 3 years. So it's inconsistent. That is the first thing that you have to say about something. If it is not even internally consistent, then it should be eliminated, right? It should be eliminated because it doesn't even follow its own rules. That is the first thing when you look at any logical argument, independently of all the external factors. If it is not internal consistency, is already problematic. Okay, it's already problematic, and so I will just exclude it for that reason. But there is even a stronger argument. We don't realize that a lot of this change that we are saying that is due to the bubbles, because we are trying to make a statement about the bubbles, is due to the growth of the power law. So you will have to adjust it. You will have to adjust. Of course, it's going down, like we're saying, it's going down. But it doesn't have to do with the bubbles. It has to do with the power law. The power law, as we explained before, has this behavior where my phone is ringing. Hopefully, it's not distracting. I can go and trying to find it, but just give me a second. Basically, I'm trying to say a lot of this behavior that we are seeing in terms of this decrease in the difference between the bottom and the top is actually due to the power law. It's not due to the bubble decreasing per se. So that is the first problem, a huge problem, because you will have to include it in your model of how a bubble decrease. So a lot of what they are describing is actually the decrease due to the fact that we're dealing with a power law. The power law behavior is such that because we are saying we are scaling things, it takes longer and longer time to go up by a factor of 10. So when we're looking at it from a linear point of view, it looks like the bubble, but there is like a decrease. There is these diminishing returns that we are mentioning all the time. But there are two diminishing returns. There is the diminishing return of the bubbles, and there is the diminishing return of the overall trend. We need to separate them. So it's a very powerful argument against this reasoning that these people give. They are not separating these two things. If you are trying to make a statement about the bubbles, and the bubble by definition are changes from the trend. This is what a bubble is supposed to be. If there is a general trend for the price, and then you see a deviation, that is a bubble, right? And so if you are trying to say that the bubble are becoming smaller and you are trying to determine by how much, do it in a way that is consistent with what the bubble is supposed to be, a deviation from the trend. You see how the argument goes? This is a logical, scientific way to think about these bubbles, because we know there is a general trend. Maybe they didn't know, maybe they didn't take into account, maybe their understanding of Bitcoin is incomplete because they don't understand there is like a general trend. We should look at deviation from the trend. And so this is what I did next. I look at deviations from the trend, that is a more scientific and more consistent way of doing it. And I like to use the Desmos app, because I want people to use themselves so they don't have to rely themselves. But you see, if you plot the differences in percentage from the trend, this is what you see. This is what you observe. You observe these changes here that I'm plotting here as a percentage difference, and you can see there is a decay. There is some kind of, and again, we are excluding the first bubble, and there is a general decay of the tops. Okay, and tops here, again, to be very consistent, we want to use not this double top, but we want to use the cyclic top. So this top, and this top. And so when we are actually including all these ones, all these values, we have only 3. So our analysis is limited by these guys, right? By the fact that we only have 3 data points. And then what we can do is to plot these 3 data points in a graph. Okay. And so this is what I did here. We are expecting to have some kind of exponential decay behavior. Okay. And these actually understanding them as some kind of a function instead of taking ratios, because taking ratio, again, is not really the most scientific way of doing it. First of all, because you immediately reduce the number. You're introducing, you're reducing even more strongly, the validity of your data by, taking the ratios, right? So it's better to take the 3 data points and then say, is there a particular pattern? There is like some kind of a function, some kind of geometrical pattern that I can associate these changes. Because if it is regular, if it is described by a function, then again, we can say maybe it's not really, due to chance. It's due to some precise behavior. But this, again, will be another regularity about Bitcoin that we don't know, right? Why is behaving in such regular fashion, even in terms of these stops? It's really weird. So we plot them because we are expecting some kind of exponential decay. And here I put the percentage deviation from the trend. Here I organize my peak as 0, 1, 2, 3, because that will be the future peak. And then you can see there is, in this type of graph, I see some kind of exponential decay, right? Because in a graph like this, the exponential decay will be a straight line, and it's a negative straight line. It's not perfect. You can see that it's not perfect, but it's pretty good. Nice pattern. It's only 3 data points though, right? If we had only 2 data points, it will be really stupid, because you can always connect 2 data points with a straight line. Okay. But that's 3, and this guy is somehow close. So it's the best we can do. So we connect it by a straight line in this graph. It is really an exponential, because if we plot this graph in a log-log graph, in a semi-log graph, because this is the log of the percentage deviation from the trend, we are going to get an exponential. This is a straight line. And look at this. There are 2 pieces of information. There is the R square that is telling us how good of a fit this is. it's pretty easy to get 0.996 when you have few data points actually. But if they are completely sparse, no. But if they are close to each other, actually you can get a pretty good R square. But what is more important is this guy. So this guy, this other piece of information that usually many of these graphs don't report, is the Pearson coefficient. And it's telling us how likely is that this alignment of these 3 points is due by chance. And is about 12%. This is what is the interpretation of this number. So it's telling us you have a 12% chance that this is actually due by complete randomness. Usually that, first of all, you will never be able to publish a paper with only 3 data points. They will laugh at you, okay? Even with this R square. But what is even more important is this P. If it is usually even in the wars of social studies, places where they don't care about really good stats and things like that, unless you have less than 5%, they will never accept it. So we should literally throw away these and say we can even not know anything about this decay. We should just throw our hands out. But we are not going to do that because it's all what we have, right? So it's okay sometimes when you have only 3 data points and you're trying to make some good estimates and some scientific hypotheses about what happens next to make kind of a tentative approach, right? You always want to show the data. You always want to be open and honest with your analysis. If you say, hey, it looks like a trend, the 0.12, the 12% probability is not statistically significant, but it's actually cool that this a small number. Probably if we had another data point, we will reach that statistical significance. It's just a question of missing data points. So we should take it with a grain of salt and with caution, but it's not completely invalid. It's actually a pretty valid scientific approach. And so what we can do then, we can extrapolate and we can say, okay, what if we continue along this line and we got this third point, that is basically the next bubble, how big of a percentage difference from the trend we expect? And it's supposed to be 78%. And so we can continue here, and this is what I did in the article. We can, again, respect the periodicity. So we know when the top is going to be. It's going to be at the end, if the periods are respected and they happen at the same time, the top is going to be at the end of 2025. So we can use I have this app that I link it here. You can use it yourself. It tells us how many days, from any date, you put in a date. You use January 3, 2009 to tell how many days they are going to be from these 2 dates. It's a really super cool app. I have a link here. It tells us that it's going to be 6,200 a day from January 3. We can plug in this in our nice Desmos app. You can also click on the Desmos app. It has already all the calculations, all the numbers here. And here we are, 100. So I put here, see how the formula works. It works in this way, 10 to the minus 17 times a day. Give me a day. I take the power of 5.82, and it tells me the general trend price, 118,000. So already this confirms that the guy is wrong. And so already, if you believe the power law, by just the trend, we should go to $120,000 by the end of 2026. And this guy says we are not going to reach it until 2028. Based on what? He doesn't use the power law. If you don't use the power law, you are blind. It's like you are flying blind. The power law is the most powerful understanding of Bitcoin that we have so far. Somebody else comes with something better, I'm the first one to say, hey, guy, you're amazing. I love you because you made me understand Bitcoin better. It's not about ego, it's about understanding. There is nothing that beats the power law in terms of precision, in terms of reliability, in terms of how predictive it is. It's amazing. So even that already destroys that argument that in this cycle, because this will be before the cycle ends, we are not going to go higher than 70,000, because these people, this is what they say. If there is this factor of 5, I forgot to say that, right? The conclusion was, from, if you go back, right, this was their argument. The argument was that if there is this factor of 5, this didn't happen yet, right? You take 5, you reduce by 5 at 22 that we had last time. We should get only 4.5 from the bottom, that is 70,000. That was their argument. And we are already showing that if you only go by what the power law says, this is why they need to include it in their little model, of how the bubbles are changing. You need to include the behavior of the power law. You already get this. But remember, we say we are supposed to get a decrease in the bubble of only, a deviation from the trend, right? We say it should not be on the trend line. It should be 78% from the trend. And so if you include that to the value of the trend, that deviation which we just calculated, we should get 210. So that is really bottom line, and very, 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 very conservative argument, very super conservative argument. And we can go further. So what I did further is say, okay, add 1 year to the 6,201, add 1 year. And so this is the 365 to the formula. You see how I added here 1 year? And divide by 0.5. Because usually the bottoms happen about 50%, sometimes 60%. But let's say we go all the way to 50%. So 50%, the top. So, and it should happen 1 year later. So we can calculate the trend value at 1 year after the top, multiply by 0.5, and that should give us the bottom. So the bottom after the top is 82,000. Okay, so even the bottom of the cycle is actually higher than these guys say. So it should go. So the bottom line is this: we are going to go all the way by the end of the year 2025 to 210. Maybe more, because it's formal, so it could be a little bit more. I don't think it's going all the way to 500. It's going to be something maybe 250, likely. And then it's going to drop all the way to 80,000. If you go 60% instead of 80,000, it's going to be like close to 70. But that are the rough estimates, and all based on real scientific argument, instead of moving your hands and, saying, oh, this is fact, when you don't understand the facts. You don't have all the facts. Don't say this is fact if you don't understand all the facts. First collect all the facts. And look at this. This is when you actually plot it all together and you have what is called the full model. I mean, it's not this amazing. Again, remember, we don't plot the first bubble. We don't try to model the first bubble. But look at this. All the other bubbles are accounted for. This is what you're seeing here is the price average over 3 months is even more evident. How close the two things. I mean, it's simple formula. From a simple formula, getting this incredible level of predictive power, it's amazing. And the reason, again, look how close we were to the bottom. We almost follow to adopt the full model. Then this is what happened. This is Fred Krueger's fault. He started, I'm kidding. But if you listen to this video, this doesn't say, he started, him and other people started to get a lot of FOMO. For some time, the community didn't even talk about ETF. Fred was one of the people that started to talk a lot about ETF, and other people too, right? They started to make a lot of noise. People got excited, a little, maybe too much. They got approved right in the beginning. If you remember, even the day of approval of ETF, it was like nobody really reacted. The price didn't even move too much. But then a little bit later, people realized how important this was, and etc. And it's not going to break, because if you look at my X account, I made an argument, and again, maybe we can go through the argument in another video, but I made the argument that is exactly what we need to actually go over there. The ETFs are nothing that are going to disrupt this growth. It's exactly what we need mathematically. And if you calculate the inflow that is necessary to continue to this power law, is exactly what the ETFs are bringing in. That actually supports the theory, because the theory says we get what Bitcoin deserves at any particular time, what Bitcoin is ready for at any particular time. Bitcoin is ready for the ETF, the ETF come in. Bitcoin is ready for a few guys that want to test Satoshi code. This is what you get. It is ready for Mt. Gox, gets Mt. Gox. This is what happens at every stage of the evolution of Bitcoin. Bitcoin gets something, like Sailor, when it was a certain particular time, Sailor was not ready for Bitcoin because he was cheating on Bitcoin, and Bitcoin was not ready for Sailor. Later, Sailor changed his mind. He started to be an evangelist of Bitcoin and buy Bitcoin like crazy. And Bitcoin say, okay, come to the family, and brought him in. There is this feedback loop of it continuous. And so it's nothing new. The reason why we are there instead of here is because we got a little bit excited. And so don't worry about drop like in the last few days. It's nothing. We should be here. We are over there. So we are already ahead of the game. What I think is going to happen in the next year is that we are going probably to fluctuate here, back and forth, maybe stay on the trend, going a little bit down, going back to the trend. But the bull will not start until 9, right? Until Bitcoin time 9, that is about the end of this year. And then we're going to reach there, and then we'll continue to do that. Okay? That is the bottom line. Remember, I posted in the last few days that you follow these patterns. If you buy here at the bottom, sell there, buy there, sell there. Instead of 64 in 15 years, you get close to 1,000. And it will be crazy, if you could perfectly time. So go and maybe cut that in half. So 500. So we're talking about several hundred more if you are actually study Bitcoin, if you understand these patterns, if you're using all the indicators that we are developing, if you join our community, because we have this beautiful Patreon community that it's in Discord, but you access it through Patreon. I will put the link in the video so you can join us if you want. We have this beautiful set of indicators. We have this beautiful community where we help each other. It's almost like 300 people now, 400 people. And there are many knowledgeable people. Some people know about options. Some people know about other things. So please join us. Come and join our family, because we are learning all these things. We are using logic. We are using science. We are using mathematics to understand this pattern. So instead of 64, which is already amazing, maybe we get 100 or 200, times our money in 15 years from now. So I invite you to understand and study Bitcoin and use the best tools. They should be predictive. Don't trust anything that is reactive. It needs to be predictive, okay? And even things that seem predictive, like this argument, the crypto crew university, if you don't understand all the steps, if you don't understand the logic, they can fool a lot of people, So it's why we are providing something alternative and something based on a more scientific understanding. So so I'm going to take some questions for a couple of minutes, and then I need to get ready for another meeting that we are having in a few minutes. If there is any questions, ask the questions in the comments, and then I will try to answer everybody, because I really need to go. We have another meeting. In fact, this is a Discord meeting. We learn how to code and how to make some of these graphs together instead of you relying on me making the graph. I want to teach you how to make them. So we are going to do this class in basically right now. It's usually at 3 p.m. PST. So this is what I'm going to do in a moment. If you have any question, please do it on X or do it here in the comments, and I promise I will answer everybody. I will try to answer your questions, okay? So I'm going to end the stream simply because I need to go to the other meeting, and I thank you to be here and to participate to this, and let me know if there is anything else that you would like me to explain, okay? Thank you so much, guys. See you soon.